Vignesh Ramachandran given by Durga Devi ma'am.
Good evening, all. I am very much to introduce Mr. Vignesh Ramachandran, founder and CEO of k-Robotix Robo Tech Center. He is the 2017 alumni of SRM Valiam Engineering College from our department. But he and a driving force is the driving force behind the conceptualization and realization of every ideas from the stables of k-Robotix. Thinking big might actually be something this person is born with. So in this leadership and directions, the products and the processes have been made highly scalable, empowering the entire team to run faster to meet goals and vision. Robotics strives to the first one but to introduce the first generation to the world of tech learning. They are providing STEM-based education and training to schools and the colleges, and also providing hands-on training on both the parts, art, construction, and safety. So, with this introduction, I hand over the session to Mr. Vignesh.
Yes, thank you for the introduction. This is very good morning, good evening for all respective staff and my juniors. I'm Vignesh from 2017 passed out. I'm running a k-Robotix Robotics Training Center. We are providing robotic trainings for the school students and college students, and we are doing projects for the college-based projects and industrial-based projects. And today we're gonna see about the robotic training. Actually, we are going to see about the electronics and electrical and software content today. The session will be continued by Mr. Nandakumar. He is a senior robotic engineer.
Hi everyone, good evening. Am I audible?
Yes, sir.
Yes, I'm going to start this session now. I'm Nanda Kumar. The session will be based on the controllers like Arduino, Node MCU, and the basic introduction about the processor. Any doubts, you can just leave a message in the chat. At the end of the session, I will clear all your doubts. Okay, shall we get into the session?
Yes, sir.
Okay. First of all, our company k-Robotix Robo Tech Center, what we do and why we choose this field is first of all the robotics field. What is robotics? Any student can answer. What is robotics on your point of view? Anyone? Okay. Robotics is a branch of engineering which deals with design, manufacture, and operation of different types of robots. First of all, why we need a robot? Anyone? Let's make it interactive. Just any one of why we need a robot. let's make these questions simpler. What is robot? What are all the electronic components you use daily in your life? Anyone? So not only for students, even the staffs also can answer these questions. What are all the electronic components you use in your day-to-day life, which makes your work easier? Anyone? Okay. The electronic components, I will say some examples. You can relate it, like washing machine, which reduces work in washing the clothes. Like that, the components which you use daily in your life is all based on these robotics components. It's nothing but automation. Robotics is nothing but an automation. First of all, the process which we teach robotics is based on this STEM-based syllabus. STEM-based syllabus is nothing but science, technology, engineering, and mathematics. Without these four things, we cannot build a robot. Science is the basic thing. I can say that in starting with an atom, everything starts with an atom. Even this world is made up of atom. Even everyone in this world is made up of atom. Without science, there is no electronics, no robotics, and nothing. So science is a major basic concept, and based on the science, the engineering, technology is made. And for making calculations and making the robotics to work at a particular angle or a particular place or particular area, mathematics is used. So without the science and maths, there is no use of these robotics components or electronic components or electronics. Okay. Next, first we go in deep about what is robotics and history of robotics. Whatever we learn, whatever we do, we have to know the base thing. That is the history of that thing. The basic history of the robot. We all just read for the syllabus and for exams, not for us. But any one student, whether you thought about why we have to read these syllabus, why have to write exams, where these syllabus and these like electronics and communication things are where it originates from. This is a history. Okay. Anyone know the history about robotics, robots? Okay. First, what is a robot? It is the basic images you see is not a robot. Robot is a reprogrammable multifunction unit, and it is an automated electromechanical machine. Okay. Robot is an automated electromechanical machine. What you do, what you do daily, which makes you more tougher your work, you have to automate it. So for doing the process of automation, this robot is found. The history of robot is the concept was introduced by Isaac Asimov. Okay, the word robot was introduced by Isaac Asimov and Karel Capek. He was a story writer. Once he was writing a story, he used to describe the slave as a robot, because robots are nothing but we command them and they do what we want. So he replaced the word with slave as robots. So like that, the organizer and the first robot was found by George Norman and Engelberger. That is called Unimet robot, which is nothing but a pick and place robot. Nowadays, we see in food factory industries and many industries the packaging and the taking it will be like our human arm. It will take our product from one to place from one place to another. This robot work under the control loop. It's nothing but sense, think, and act. what we do. Okay, usually we have to sense the situation and we used to think about it and we have to act. The same process only we use for the robots. So for us, there are different kinds of senses like speech, vision, and temperature, touch, taste, like that. So like that, we have to. We are all living things, right? So we have to give those things to a non-living thing. So we give it through as sensors. Okay, sensors, we use different kinds of sensors in different types of industries. For example, in cars we use accelerator sensor and touch sensor, like that. So based on the applications, we use different types of sensors. And these robots are made under these three laws, major three laws. The major three laws are zeroth law. It's nothing but a robot. This is the first law. It is common to every robots we make. It's nothing but robot may not injure human. Any robot we make should not injure any living thing in this world. And the first law is same as the zeroth law. The robot should not be harmful to others. And second law is the robot must obey the master's command. And the third law is robot must protect itself.
Excuse me, sir.
Yes.
No.
Yes, sir.
Sir, are you sharing your screen, sir?
Oh, 1 second, sir. Can you able to see my screen, sir?
No, sir.
Started loading. Started loading.
Yes, I think it's loading.
Is it visible?
Yes. Yes.
Okay, sir.
So can you put it in presentation mode?
Oh, yes, sir.
Slideshow.
Okay, sir. Is it visible?
Yes, sir. Yes, no. Thank you. Thank you, Nandamur.
Okay. As of now, I told that I discussed about what is robot. A small recap. Robot is an automated electromechanical machine. It involves four processes. It's nothing but automation. The automation can be done by software engineers, like programming a robot, which is a major part, and electromechanical machine. Electro is nothing but a combination of electrical and electronics. Electrical and electronics, like controllers and sensors and different types of boards we use to program them. And mechanical, the whatever we do, for example, our mobile phone, every electronic component in this world has an structure, different types of structures. For example, laptop outer structure and a cell phone outer structure. These types of structure, we make them in a specific model, then only we can buy it. So the structure made by these components will be done by the mechanical engineers. Okay, robotics is nothing but study of robot and its technology. What is robot is nothing but designing and building an application to make that robot to do our work automatically. Why robotics is needed is basic thing is speed, temperature to work in a hazardous and dangerous temperature place, and to do repetitive tasks and to work with accuracy. The difference between the machine and a robot is a robot can be reprogrammed, whereas the machine cannot be reprogrammed. For example, a difference between an Arduino microcontroller, which I will be sharing in a few seconds, and reprogrammable. Robot Arduino is reprogrammable, but the washing machine controller are not programmable. And multifunctional. For example, there are different types of electronic instruments or machines in your home that will do only specific tasks. For example, washing machine will only wash your clothes, Oven will only heat. Refrigeration will give only make the products cool. So with this robots we can do multifunction. This is the major difference between this and manipulative. Manipulative means basically we can make the thing what we want to do. We can control it with our commands. Okay, next, as I told, control loop: sense, think, and act. Next, I share the laws of robot. These are the legends who found the concept robotics in the year between 1890 to 1938, and the first robot was found in the year 1964. That is called Unimate robot. The big and the guy with the in the right side is Isaac Asimov, who framed the law for robotics, and the guy in the left side is Engelberger, who is the inventor of the world's first robot, Unimate, that is called a pick and place robot. So this is the world's first robot, pick and place. It used to take the product from one place and place it in the destination we program. Technology is based, the robotics technology is based on the sensors, effectors, actuators, controllers, and arms. Sensors, as I said before, sensors. The basic sensors or IR sensors, ultrasonic sensors, we use to interface with Arduino. And industrial level sensors also be used. For example, a car manufacturer industry uses around 60 to 70 sensors in the car for manufacturing. So like that, based on the application, the sensors also vary. Okay, effectors is nothing but end of the robotic arm. That end of the robotic arm is nothing but the Unimate robot used to pick a product from one place, right? So that end of the robotic arm is called as effectors. Actuators, which moves the robotic joints, that's called gears. Okay, next, controllers. Controllers, there are many controllers. Arduino, Node MCU, and processor like Raspberry Pi, which acts as the brain for these robots. Okay, next, these are the sensors, effector, and controllers, arms. And next, we move on to types of robot. There are rolling robots. There are different types of robots based on the applications we make. Now I'll concentrate on the components. First of all, electronics. What is electronics? Anyone? Okay. As of I said that robotics is nothing but study of robot and its technology. Electronics is different types of electrons and its types and how it works with one another. Okay. This electronics is a study of flow of electrons in various materials or space subject to various conditions. The main focus of the electronics remains the controlled flow of electrons through a medium. For example, anyone can tell a basic difference between the current and voltage. Either both are same or different. Current and voltage. Anyone? Okay. The basic difference between the current and voltage is both current and voltage is not the same. Current is nothing but the flow of electrons and the force of the electrons to move from one place to another or through from one medium to the one end of the medium to the next end of the medium is called the voltage. Okay. And the basic types electronic components, it is divided into passive components and active components. Passive components consist of resistors and types of resistors are there based on their needs and capacitors. And so there are different types of capacitors and inductor. First of all, what is resistor? Resistor is nothing flow of current. Anyone know about the water analogy? Anyone? So electronics is a study of electrons and its components passive and active. Passive, the difference between the passive components and active components is the external source. Passive components doesn't need any external source, whereas the active components requires an external push to operate. Okay, first of all, resistors. Resistors is nothing but it resists the flow of current. When we give voltage, that is a 230 voltage and ampere directly to an electronic device, it may damage. To avoid such things, we use resistors. These types of electronic components will help us in removing this. There are different types of resistor also, and their values are varied based on this color coding. Next, potentiometer, photoresistor. These are different types of resistors. Capacitor, inductor. So capacitor is nothing but it stores charge between these two plates, electrical charge, and is discharged slowly once we switch off the power. This operations is mainly carried out in fans, etc. Next, inductor. There are only two major components in the science. One is electrical energy and mechanical energy. Without these two things, science is nothing. Capacitor stores the electrical charge and inductor stores the magnetic charge. These are the difference between these two things. And the major application of the inductor is transformer. Active components. Active components is nothing but it needs an external push to operate. For example, such as our TV, we just switch on the TV and like AC also. If it's not AC, it does not on directly. We have to give an external push through remote. So there we use an active component. Okay, active component first is a diode. It allows the current in only one direction from anode to cathode. Diode. These are types of diodes. Transistor. It acts as a switch and it acts as a gate between the power flow. The operation to on and off and to send and power to one device to other is based on these transistors. There are three terminals: base, emitter, and collector. These are all maybe the basic things, but we have to concentrate in this because all the bigger things comes from a smaller thing. Okay, so without knowing this, we cannot do anything bigger. So everything we do is based on this batteries. Okay, then power supply. Other than the electromechanical components, it's an electronic component which is operated mechanically, such as switches, relays, circuit breakers, and here is a breadboard. Before giving a wire connections directly through a PCB board and soldering it, we can check through this breadboard. Okay. And this is a printed circuit board. This is a basic PCB designing, which we also have a separate course for PCB designing. Students who are interested in PCB designing can also contact us because we teach basic and till through the printing the circuit board. Okay, we have separate course for this, and we have separate course for robotics also. You can check our profile for more courses also. We offer more courses regarding aero modeling, PCB, PLC, and AutoCAD, etc. For courses and projects intern, you can ping us in our mail. Okay, next we move on to controller. Controller, first we are going to see the controller. Arduino, and we will do some experiments like simulation. We will do it online, and that will be our end of the session. Arduino. Anyone, most of the college students may know, come familiar across this Arduino. It's not. Can you answer whether it's a microcontroller or a processor? Anyone?
Microcontroller.
Microcontroller. Very good. May I know your name, please? Your name? Okay. Arduino is a microcontroller. One second. Can you hear me?
Yes, sir.
Okay. There is some network issue, so sorry for the trouble. So anyone can tell about the difference between the microprocessor and the microcontroller?
Microprocessor is only CPU.
Sorry?
Microprocessor only CPU,
Okay.
but in microcontroller we can input join in memory to CPU.
Okay. Any other difference? Is the screen is visible now?
Yes, sir.
Okay.
Yes, sir.
A microprocessor is an electronic component that used by a computer to do its work. The microprocessor, the basic difference between the microprocessor and microcontroller is these are the boards. I'll show you basic difference between these two. Okay. The processor, you see, it contains only processor, ALU, and registers. Anyone can say what is ALU? For example, microprocessor is nothing but it's our CPU. Like we have to externally interface ROM, RAM, input and outputs, and serial communication externally. It's just only a processor, whereas the controller, it consists everything inside it. This is the basic difference between the processor and the controller. And these are the major difference between the microprocessor and microcontroller, where microprocessor is heart of the computer system, microcontroller is the heart of the embedded system. Embedded is nothing but we interfacing the ROM, RAM, and timer input output port externally to microprocessor, right? In this microcontroller, everything embedded inside it. Embedded is nothing but joined inside it. Okay, it is just a processor. Memory and input output components have to be connected externally, as I said now. And the cost of the entire system in microprocessor increases. Microcontroller, it is low. The most compact your system is, the amount will be reduced and the heat exposed will be reduced. Okay. And the main major thing difference is personal computers is a major example for microprocessor. And microcontrollers, as I said, the washing machine, MP3 players, microwave oven, and the electronic components use all are microcontrollers. Now we can see the different types of boards in microprocessor and microcontroller. First of all, AVR. AVR is an the chip is an microprocessor. This is a microchip. PIC. These are all microchip for microcontrollers, and this is a major controllers now we use. Atmel AVR, Atmega 3 to 8, which is the chip we use in Arduino. PIC 18F877A, 8051, Arduino, and ARM. And the components we see in both controller and processor is central processing unit, input output, bus, addressables and data bus, RAM, ROM, timer, interrupt, serial port and parallel port. Okay, this is the basic difference. Now we move on to Arduino. What is Arduino? Arduino is an open source electronic platform which makes our code easier and makes us easy to understand. That's why it's an open source. And the boards we use also we can easily learn. Within a short period of time we can learn the controls and how to program the board. So only this is an open source and everybody can easily access it. So these are the different types of Arduino boards. UNO, Mega, LilyPad, Arduino Bluetooth board, Arduino Nano, Arduino Mini and Arduino Pro Mini. There are different types of boards in Arduino also. Now we move on to the parts, because today we have an hands-on session in Arduino. The Arduino UNO has different types of ports. First, digital input and output port and analog input port. Okay, there are 14 pins in digital and 5 pins in analog in Arduino UNO. Now we concentrate only in Arduino UNO, and further boards. If you want to learn more about electronics and different types of board like Raspberry Pi processor and microcontroller like Node MCU, you can reach us at any time. To our office is located in Chengalpet. You can call us regarding any robotic courses you want. We provide certification also. Now we move on to this Arduino types, and it has a USB port. USB port is used to program the board, and the power input. Either we have to give the power supply through USB port or after programming, or through this power input. And the analog input, there are 6 pins, 6 analog pins and 14 digital pins. Anyone can say difference between the analog and digital. What is analog? What is digital? Okay. Now I am communicating with you people, right? In the form, the audio is in communicating with my system. This is the basic difference. The digital is nothing but whatever I give input through the keyboard or mouse, it will go as zeros and ones. And I'm communicating with you, right? It is an audio signal and it is in the waveform. That is called analog. More than digital, analog is more accurate than digital. Okay, and here is a power supply port. There is a 5 volt pin, 3.3 volt pin, 2 ground pin, and pin. These are the basic parts of Arduino. You have to know. And there are some other parts you come across like oscillator. It's for time, the time take to load the program. And this is the Atmega 3 to 8 chip. The whatever we program code through Arduino IDE software will store in this chip only, and this chip will act as the brain, and it will go commands to the sensors and outputs like motors and LED buses. Okay, and this is an ISP programming. If you have, it's an external option that you can program through this ISP pin also. In circuit serial programming, you can do the program serially through this pin also. These are the basic parts of Arduino UNO. Next, we move on to the coding part. The software we use Arduino IDE. It's an open source software. You can download it through the Arduino software, Arduino IDE. Okay, it's in the homepage also. It's free only. It's no cost. If you want to learn programming, or else if you are want to code yourself to any microcontroller, you can just download it from the Arduino homepage and you can easily access it. There are many tutorials. We also post these types of YouTube videos in our YouTube channel k-Robotix. You can also view that, and any other doubt you can directly contact us. Okay, next, this is the setting of the software. You have to first download it and install. For basic programming, we need to know how you have to give the input and how you have to get the output. Okay, these are the basic data types: integer, character, long, floating point. Anyone who knows the programming knows about this well, I think, because integer is nothing but the numbers, integers you give. For example, I have to give my age. Age is equal to 23 or something like that. We use an int, age is equal to 23, like that. So next, character, I have to give my name. Character, my name is equal to Nanda Kumar, like that. Next, long variables, you have to give enlarged variables, like that means you have to use long. Next, floating point. Floating point is nothing but a decimal point including with alphabets, and there are different types of operators also. Statement operators. These Arduino programming is a little case sensitive more than other, but it is easily you can decode the error also, debug the error also. For example, the semicolon is most important when a statement at the end of the statement. Okay, that is a major thing. And there are different types of math operator like addition, subtraction, multiplication, and division. Logical operators and or XOR, gate, like that, and comparison operators. These are all you may already come across. Next, compound operators like increment, decrement, etc. Next is a basic control statements. You may come across this in any labs. This is a basic programming, embedded C programming. Okay, if condition, conditioning statement, if or else. Okay, if the condition is true, it will execute, else it will terminate. Next, switch case, you can give different cases. At that point, how many outputs you need, you can switch and break the outputs. Do while at what time, at which time you have to do the operation, we can use this command. Loop statements, these are all loop statements: while, do while, for loop. Okay, these are all the basic commands you get. There's a code structure will be like that: void setup, void loop. First you have to code, set the input and output ports, and what are all the input pins and output pins in the void setup. And the void loop is the major main function area where you will code the main function in that part. And this is an example program for LED blinking. I will set the pin mode. I will set the pin mode, digital read button, write button, and I will set the time, delay time, how much time the LED should blink, and other functions. And I will read the pin. Once I read the pin, the LED will blink. Now I will see it through. I will show it through the online. If anybody is logged into with the laptop, just open Tinkercad. So you can, it's also an open source. Just you can log in with your mail ID. Anybody interested can log in through Tinkercad and do the experiments what I do now. So this is the login page. After I log in, you can move on to circuits. It's also, you can do 3D designs also in this website. This is an online simulation software. First, you can be well trained with this, and you can move on to the programming part. Here I already worked with some designs.
Excuse me.
Yeah, ma'am, I will. Yeah.
The browser is not
Yes, ma'am. The network is slow, so that only. No issues. I will make it. Is now visible.
Yes, sir.
Okay. So this is the home page. Once you type the Tinkercad in the Google, it will open, and you have to log in with your. In the right corner, it will show you sign in, join now. You have to sign in with your mail ID. Then you can work with create new circuit. You have to select circuits and you have to create new circuit. And this is the simulation area we work. Okay, and these are the components. As of now, I just gave an intro to electronic components, right? Resistors, LED. You can search. The components will be limited here. Once you learn these components, you can work with hardware also. You can just simulate here, and you can work with hardware also. First, we will do a basic LED blink using Arduino. You can search battery here. You can just drag and drop in the workspace. Battery. I hope everyone knows the breadboard connections. The person who don't know the connections, here is the positive and negative side. This is a horizontal connection. Once you give a voltage here, it will be common to this line fully, and that's the same as here. Here it will be a vertical connection. Between these two, there will be no connection. Same wise, between these two, there will be no connection. Okay. Next. And as LED has a two ends, cathode and anode. Anode is a positive side and the cathode is a negative side. This is a basic LED blink. Okay. This is a basic LED blink. I can give it directly, but first I will give it directly. It will show an indication. I can give it directly also, but it will show an indication that the LED will be blast because it is a 9 voltage battery. The LED limit voltage is only 2 volt. It can withstand only 2 volt. Okay, so only it shows a spark. It cannot withstand 9-volt battery. So we use resistors. Here is a start simulation, stop simulation option, which you can run your program. So I will give it here, same voice. I will give it here. So you can take anywhere from this line. You can take anywhere from this line negative. So for example, I'm taking this as a negative side. I will give it connect to the cathode, and I will take here from the positive side. So the common resistor we use for LED is 220 ohms, which is the value of the resistor. You can give 1K also. So before we flash, now the LED is showing. Is it visible? You can see the LED glowing. Is it visible? You can change the color also. Okay, this is a basic LED blink. Basic LED blink. Now we will do it with audio. Okay. Conserve. So here is a board. You can just drag and drop here. This is what the Arduino board look like. So you can place it wherever you want. So as of now, I told you the components, right? These are all the analog pins, and these are all the digital pins. Now we do the basic blink experiment with this LED and resistor, and we will do a sensor interface, and that will be the end of our session. So one you have to connect to the ground, and the other end you have to connect to any one of the pin. Okay, and now we have to code the Arduino. Here it will be in the blocks type. Now we have to set it to the text. Continue, and here is the mode. Everyone just listen to the code. Here this is a basic code through which we can code many. This will be the basic to the larger codes also. In this void setup, we will set the output pin as 13. Okay, pin mode 13, and it will be the output, because LED is our output. The input is nothing but we give in the code that here this will be the command digital write. Just we are writing digitally to the Arduino Atmega 328 controller IC that pin 13 must be given supply high. Okay, I said that it is a digital, so 0 means high, 1 means low. Okay. Okay, delay. 13th pin, it will be high. It will give a delay time That's 1000 millisecond. It's nothing but 1 second. And digital write 13 low. 1 second it will be off. Okay, now we can start the simulation. So the LED will on for 1 second and it will off for 1 second. Okay. So you can change the code for your clearance. I will change the pin number here. Pin mode, I'll set the pin as 10. That will be the output. I have to change it throughout the code. Okay, I also will change the 3 seconds. So I will now start the simulation. So the LED won't blink because I didn't change the connection. I have to change the connection to the 10th pin, then only the output will be correct. So LED will be on for 3 seconds and it will be off for 3 seconds. Okay, this is the basic coding in Arduino. The further codings we may proceed is also based on these basic concepts in what we have to give the input and output. And in the void loop, we have to give the command that what we have to do or what we have to get. This is the basic coding. And as a end of the session, we will see a one sensor interface within Arduino, and that will be the end. Anyone come across the PIR sensor? What is IR? PIR? Anyone? Anyone? So this is the interfacing the PIR sensor with the Arduino. Every sensor has a common pins, that is a signal pin and a power pin and the ground. This project I already worked before a month. The signal pin will be given to the any digital output, digital pin of the Arduino, and the power pin will be given to the 5 volt and the ground will be given commonly. So here anyone can tell which is input and which is output. First of all, what is a PIR sensor? PIR sensor is nothing but a passive infrared ray sensor. IR, it's also an IR, infrared ray. We use it in our daily life because the TV remote and the AC remote and we control through the devices. We control the remote is based on these IR infrared ray applications. Okay. This passive infrared ray is it will expand the infrared ray around 180 degrees straight. So passive infrared ray is used for motion. It's also known as for motion sensor. It's mainly used for home security systems, etc. When we place it, a major application of this project is whenever we place it in our nearby our door, or once we are not in the home, we place it in our nearby door. Whomever tries to break into our home, it will give a signal to the buzzer. Okay. As a result, the buzzer and LED will glow. The buzzer will horn. So there is a home security system concept. I will now tell you the connections. PIR signal sensor is signal pin. That is, PIR sensor is the input and buzzer and LED is the output here. PIR sensor is connected to the 8th pin. The power is given to the 5 volt and it is grounded. Next, the buzzer pin is connected to the 11th of digital pin and it is also grounded here. Next, LED is connected to the 5th pin and it is also grounded. Okay. Without these proper connections, we cannot get the exact output. Okay. We have to ground all the electronic components, else we won't get the output what we expect. And we'll explain your code. As I said, what are all the pins we given connection? We have to declare here first. Int buzzer is equal to 11. Integer. As I said, while taking the data types, I said that integer buzzer is equal to 11, sensor is equal to 8, LED is equal to 5. And void setup. Pin mode. Buzzer is the output, sensor is the input. When it senses the motion, it gives an input to the Arduino. As a result, Arduino will give an output signal to the buzzer and LED. So LED is the output. Digital write. Buzzer glow. First, we giving a condition that each and every electronic component is in the off state. So when we write here, we give the command for the LED to blink. That is, whenever the PIR sensor senses, the LED will blink at a specific time. So we give here a command that while milliseconds, that's nothing but milliseconds. So it will blink at a specific delay. So in the loop, we given a command that if digital read sensor reads any motion or any disturbance, it will be high, the buzzer will be high, else the buzzer will be low. This is the basic command. As of I said, the LED blink program is a basic for every command. The command will be followed for any project you do or any concept you take and do. The concept will be the same. You have to change the input and output pins. That's it. Or else if you have to add any input and output, you have to add. Okay, now we run on the simulation. So at first the LED will blink with a specific delay. Once it senses, so as I said, the PIR sensor will emit the IR rays around 180. When it senses, the buzzer will give this is the buzzer indication. So once I stop, the buzzer will stop. Again, I will start the simulation for you. The LED will blink at a specific delay. Once the PIR sensor senses the motion, the buzzer also here. See, there is no indication in the buzzer. Once I point here, there will be it senses the motion, and the buzzer will also make a sound, and the LED also will stop blinking. Okay, this concept can be implemented in the home security system. That when we place this PIR sensor in the front of our home or near to the door, anyone who tries to break into our home, it will sense the motion and it will generate an alarm. And also LED. It can be also interfaced with an IoT. Like that, it will directly send a message to our phone or else capture and send the location to police station. Like that, this is a major application of this project, and this is a prototype of that project. You can also do it in hardware. Okay. And once again, I'll run the simulation. Once again, I'll run the simulation. So here is the okay. Okay, the buzzer will stop the sound. Once it will be out of 180 degree, it will stop the sound. Again, if I go inside, the buzzer will start giving the alarm. So as of now, this is what all robotics is. Just in a bit, not a bit, not even a bit. We offer more courses for college students also, college students, school students. I'll just given details about the courses we offer. We offer robotics courses for college students and pre-project training courses. The final years can make use of it. They can also attend the intern instead of doing the project in the project centers. They can make an internship in our company, and we will provide a certificate also for that intern, and we will make them to do the projects on their own, and we will train in that specific concept. We will train them in that specific concept. Okay. For details, I'll flash our. You can contact us. k-Robotix, you can contact us through www.k-Robotix.com. Our details are established in our homepage also, and the what we do and what we do, we will update in our YouTube channel also. You can just view through the YouTube channel also, k-Robotix YouTube channel. So this is our contact. You can contact anytime. This is our number, colleague number, and it's my number. Website www.k-Robotix.com. Email k-Robotix.kbx. For any queries, you can email us also. For further clarifications, you can mail us anytime. So this will be the end of this session. Sir, thank you for the opportunity, sir.
Thank you.
Thank you.
Mr. Nandakumar. Thank you.
Thank you.
Dear participants, I have posted the feedback in chat box. Please fill the feedback. Okay. I like to express our sincere thanks to our management, and other faculty members for their support and their valuable guidance. I must mention my I like to mention special thanks to Mr. V. Nandakumar for his valuable presentation. We are inspired by your presentation, sir. Your presentation on hands-on training in robotics and Arduino and then Arduino ID. It's a useful session for our students, sir.
Thank you, sir.
I'd like to thank our thank you, sir. I'd like to thank our both internal and external participants. Students, please fill the feedback form, which is available in our chat box, and then you can leave. Thank you. Once again, thank you all.
Thank you, Nandakumar sir.
Thank you, sir.
Convey my thanks to thank you, Anbarsan sir, and thank you.
Sir.
Sir, conversations turned off now, sir.
Conversations.
So stop sharing கொடுத்துருங்க. Stop recording, sorry. Stop recording.
Stop recording.
Conversation
Have been turned off now, sir.